In this video we're going to talk about an introduction to problem solving and solving story type problems, real life problems. The focus of this is going to be translating words into mathematical symbols. We need to start thinking about math as another language. Sometimes it feels that way. We don't know what the symbols mean or what the words mean, and if you approach math like a different language and try to translate it into English, it can really help you understand certain types of problems. So we're going to start off with some common symbols. The first symbol is the addition sign. And I said addition sign, but what I'm really looking at here is this symbol, and that symbol can be interpreted in many different ways. It could be the word add, the word plus. This is a word right here, sum, that you may or may not have seen. It's not quite as common. Increased by or more than. All of those English words can be translated into this mathematical symbol that we would think of as a plus sign. Let's look at some examples. A number of oranges G plus number of apples A. So in this case, G represents the number of oranges and A represents the number of apples. So how would we translate this phrase? Well, that would be G plus A. Again, our keyword here in bold, plus, is translated into this symbol. That's pretty straightforward. Let's look at another one. The sum of the boys B and girls G in class today. How would we find the sum of the boys and girls in class? Well, sum means plus. So if we have B boys and G girls, the sum would be B plus G. How about the width of the rectangle W increased by 4 feet? Can you guess what that would be? Take a guess. The width of the rectangle, which is W, increased by 4 feet. That would give us W plus 4. The keyword increased by. And lastly, I have 6 more than Tommy's age T. If Tommy is T years old, we don't know how old he is. He could be 10, he could be 15, he could be 25. We're just going to say he's T years old. How would I find 6 more than Tommy's age T? Hopefully you said 6 plus T. So here we've got some examples of how we would use addition or adding this plus sign in different situations. Next, let's look at this common symbol. Typically we would read this as minus or subtract, but another word that is less well known is difference. That means to subtract two numbers. Less than and decreased by. Let's look at a couple examples. The gross pay G minus deductions D. The gross pay is what you get paid before they take out things like taxes or any insurance or deductions that you might have taken out of your paycheck. So how would we find your gross pay minus your deductions D? G minus D. That's pretty straightforward. All right, let's try another one. Here's that difference word. The difference between the high temperature H and the low temperature L. Well, to find the difference, we subtract. So we would take H minus L, the high temperature minus the low temperature. You try this one. 5 less than the length L. Now we'll tell you this one's a little bit tricky. What do you think it would be? 5 less than the length L. The answer is L minus 5. It's in a different order than the way it's written in English. 5 less than L means we have to start with L and then subtract 5. So you got to be careful with that less than. It's going to switch the order. If it's 5 less than L, you have to start with the L and then take away 5. If you were to write 5 minus L, this would be a different thing. This would not represent this phrase. 10 less than the amount Tom made T. So here's another one with less than, same as the one we just did. Let's see if you can get this one. Hopefully you said T minus 10. Tom made T dollars. If I want 10 less than that, I have to subtract 10 from T. T minus 10. Our next symbol is a common symbol here. This big X, usually meant to mean multiply or times. This word product is not as familiar. That means multiply. Twice is a specific type of multiplication. It means to take 2 times something. Similarly, triple means to take 3 times something. Now this word of is typically known by people to mean multiply, but it really only means multiply in a couple of situations. If you have a fraction of something, you're going to multiply that fraction by something. Or if you have a percent of something, and there'll be a number here or a value. Let's look at some examples. The length L times the width W. That would be LW. Remember, when two variables are written right next to each other like this with nothing in between, it means multiplication. The product of the hours worked H and the rate of pay P. Product means multiply. So we're going to multiply the hours worked H and the rate of pay P, which we would write simply as HP. Now you may see this written as H parenthesis P or parenthesis H parenthesis P. These mean multiply as well. In mathematics, we want to try to write things as simply as possible. So the HP right next to each other is the simplest way to write this and the way that you're going to typically see it written. Some of you may be thinking, well, how about this? H times P. In the past, this little x has meant multiplication, as I've shown here with this big symbol with the big old X. But as we move more towards algebraic writing, we don't use a little x for multiplication because x is going to be used as a variable. So we want to move away from using this symbol. So other symbols for multiplication are parentheses or simply just having two letters next to each other. That infers that they're being multiplied by each other. Here's twice. Twice the time t. Remember, twice means 2 times. So you could rephrase this as 2 times the time t, which would be 2t. So in other words, if it takes t time to mow the lawn and your little brother takes twice as much time, he would take 2t. Here's an example of a fraction of 2/3 of the cost of a large pizza P. So in this case, our fraction is 2/3. So we're taking 2/3 times the cost of a large pizza, which is P. And we would write that 2/3 P. You could also write it like that, your fraction 2/3. Here's a percent example, 23% of the population P. So in this case, because I have a percent and then the word of after it, this is going to mean multiply. 0.23 P. Notice in this example, I took my percent and changed it into its decimal form by taking the decimal in 23, which is not written, so it's at the far right-hand side, and moving it 2 places to the left. And that changes it to its decimal form of 0.23. Next we have this common symbol, which is typically known as divide or division. A fancy math word for it is quotient. Another way to think of division is if we talk about splitting equally. If I have 25 cookies and I want to split them equally amongst 5 people, that would be a division problem. Let's say we have the cost per year, Y, and we want to divide that by 12. Divided by 12, how would we write that? We could write it with a division symbol that I've shown up here, or you could write it with a fraction bar. Remember, a fraction bar means divide as well. How about this one? The quotient of the distance D and the rate R. Quotient means divide, so I want to divide the distance and the rate. D divided by R, or D fraction bar R. You try this one. Here we are with the cookies. I must have a thing with cookies. All the cookies C split equally amongst 5 children. How would I write that? Hopefully you said C divided by 5 or C over 5. You could also write it like that. That was our last example. Okay, so now we're going to talk about some other situations using multiple operations. In other words, when I talk about operations, I'm talking about add, subtract, multiply, and divide. So this problem may have more than one of those operations. Here we have a rectangle, and we want to find the perimeter of this rectangle. This rectangle has a width W, which I've shown right here, width W, and the length is 4 more than the width. And that's where this is coming from. This is your length right here. Oops, kind of went downhill there. And it's 4 more than the width. If the width is W, then the length would be W plus 4, because it's 4 more than the width. So now we have to talk about perimeter. What does perimeter mean? Perimeter is the distance around an object, and we find that distance by adding up the sides. So to find the perimeter of this rectangle, we would need to take W plus another W for this side over here, that's these two W's, plus W plus 4 for the top, and another W plus 4 for the bottom. So this expression right here would represent the perimeter of this rectangle. Now we couldn't solve this or figure out the value of W unless we knew what the perimeter was. Right now we're just practicing translating these English words into these mathematical symbols. Now some of you may have some experience with simplifying expressions. If you do, you might be thinking, I could write this another way. I could write this as 2 W's. So this 2W right here is representing the two widths, and then this 2 times W plus 4 is representing the two lengths. If I wanted to simplify that further, I could take this 2 times W and 2 times 4, which would give me 2W plus 8. And lastly, 2W plus 2W is 4W plus 8. Any one of these 4 steps could represent the perimeter of the rectangle. And if we're in a situation where we're solving equations, which we're not quite there yet in this presentation, we would have to simplify these expressions in order to solve it. But for right now, we're just hoping that you can take these words and translate them into one of these mathematical expressions. Let's look at another example. The average of the amount paid for electricity over 5 months. And these are the amounts that were paid each month. $75, $83, $92, $78, and X dollars, some unknown amount. So this is your 5 months. How do we find average? How do we find the average? Well, hopefully you remember to find average, you add all the numbers that you have, and then you divide it by the number of numbers, which is a kind of a weird thing to say. But in other words, how many numbers did you add together? So in this case, we're going to add 5 numbers together. Our number of numbers then is 5, or the number of pieces of data might be another way to say it. Okay, so think about this now. How would you write this out? The average of the amount paid. How would we find the average of these 5 values? Maybe you could pause the video if you have an idea and write it down. Alright, well, we know to find the average we have to add all these things together. So we want to take 75 plus 83 plus 92 plus 78 plus X, and then we want to divide that whole thing by 5. So let's see what that might look like here. We could write it like this whole thing added together, close the parentheses, and divide that whole thing by 5. Now we're using a fraction bar for divide by 5. Another way you could do it is take the 75 plus 83 plus 92 plus 78. You could add all those up if you want and get the number, whatever it is, plus X. Don't forget your X. Even though we don't know what X is, we still have to add it in there. And then you could use a fraction bar for divide if you want and put the 5 on the bottom. Now if we knew what the average was, if we knew what this number was, over the 5 months, we could find the value of x, and that'll be the next thing that we'll learn how to do. Now let's talk about the difference between equations and expressions. Equations have equal signs. All of these are examples of equations because they have equal signs. An expression does not have an equal sign. These are all examples of expressions, and we've basically been working on expressions. We haven't had equals. If we did have an equation that was equal to something, we would see in our story problem, in our English words, something along the lines of equals or is equal to or the word is. A couple examples. Start with a really easy one. 1 plus 1 equals 2. We want to translate this. Now we have the word plus, which we talked about, but we also have the word equals. So instead of an expression, we can write an entire equation. Let's try another one. The area of a rectangle A is equal to its length L times its width W. Our key phrases are is equal to, which we know is this symbol, and times, which we know is this symbol, or possibly parentheses, or possibly just writing two things next to each other. That's one thing about multiplication. There's a lot of different ways to write it. So can you picture what this would be, this formula, this equation? A equals LW. That means the area of a rectangle A is equal to its length L times its width W. Here again we have an example of the times being represented with the L and the W right next to each other with nothing in between. This is supposed to be a L right here. This font looks a little bit like a 1, but see, there's an L right there. That's what that font looks like for L. You try this one. This is going to be an equation because it has the word is present in the sentence. The sum of x and 5 is y. Remember what sum means? It means addition. X plus 5 equals y. The sum of x and 5. When you have this word sum, you're going to see an and very shortly after the word sum, and that's where your plus sign goes. The sum of x and 5 means we want to add x and 5. So x plus 5 is equals y. Alright, let's look at a couple real life situations and try to write an equation. Juanita makes $15 per hour. When she works on a holiday, she makes twice as much per hour. In a week she worked R regular hours plus 7 holiday hours. She made $540. Now that's a lot of information. Let's see if we can pull out the important pieces of information. We know she made $15 per hour. So I've got that here, $15 per hour. And she gets $15 per hour for every regular hour, which is a non-holiday hour. So however many non-holiday hours she works, we're going to multiply that by 15, and that'll tell us how much money she makes for those hours. Plus, in addition, she gets $30 for every hour she works that was a holiday hour. So however many holiday hours she works, we have to multiply that by $30 because that's how much she gets paid per hour. Now where did I get that $30? I don't see a 30 up here anywhere. Can you see where I got it? It's right here. Twice as much. When she works on a holiday, she makes twice as much per hour. Twice as much as what? Twice as much as this 15. She usually makes $15 an hour, but on holidays she makes twice as much or 2 times as much, and 2 times 15 is 30. So that is where I got the 30. Now if we add these two dollar amounts together, we're going to get her total amount that she made, which the problem told us was $540. Well, we have one more step to go. We want to put something in here for the number of regular hours. Do we know how many regular hours she worked? Does it say up here? Let's see. In a week, she worked R regular hours. So that's going to go right here for the number of regular hours. And how many holiday hours did she work? Plus 7 holiday hours. So we would want to substitute those in. Regular hours R, and holiday hours 7. So our equation would be 15 times R. That would give you how much money she would make for her regular hours, plus 30 times 7, which would tell you how much money she would make for her holiday hours, and that's going to total $540. We're not going to talk about solving this equation in this video, but that will be the ultimate goal, to solve the equation. Let's look at one last example and try to write an equation. 3 members of a cross-country team ran a total of 29 miles at practice today. Tom ran M miles, Anna ran 1 more mile than Tom, and Sam ran half of Tom's distance. A lot of information here. Try to sort it out. How many people do we have? We've got 3 people, and they ran a total of 21 miles. So what do we need to do with those 3 people's mileage to get 21? Hopefully you're saying we need to add them together. Tom's distance plus Anna's distance plus Sam's distance has to equal 21 miles. And I'm getting that from basically this word here. They totaled or added up to be 21 miles. Once you have the basic shell of how you want to write your equation, now you can just plug in some more detailed information. We need Tom's distance. How far did Tom run? Let's go back and look. Tom ran M miles. We don't know exactly how far he ran, so we're going to call it M. How far did Anna run? Anna ran 1 more mile than Tom. So if Tom ran M miles, how far would Anna have run if she ran 1 more mile than Tom? Well, you would take Tom's mileage and add 1, because Anna ran 1 more mile. Sam ran half of Tom's distance. Remember a few minutes ago we talked about a fraction of? What does that word of mean when it comes right after a fraction? Multiplication, that's right. So we want to take half times Tom's distance. Remember Tom's distance is M. So Sam ran half times Tom. 1/2 times M. If I write the 1/2 and the M right next to each other, that means multiplication. So after plugging these in, we get our equation. This M is Tom's distance, plus M plus 1, which is Anna's distance, plus 1/2 M, which is Sam's distance, and that totals 21. Again, your next step is probably going to be to solve this equation. But most people need to really practice on translating the words into symbols, and once they learn how to solve the equations, it's fairly straightforward from there. A lot of people are intimidated by story problems, but problem solving can be fun. Think of it as a puzzle. Think of it as a brain activity. Hopefully you like some kind of puzzles, whether they be word puzzles or number puzzles or jigsaw puzzles. And if you think of a math problem as a puzzle that you're trying to solve or unravel or make fit together, sometimes that can make it more fun.